Most people believe that building a chip factory is something reserved for Asian giants with decades of accumulated experience. What few people know is that in April 2026, diggers began tearing up the ground on the northern side of the Giga Texas complex. And what is being built there could double the entire computing capacity of the United States. A $25 billion project. 2-nanometer technology, 4 companies that rarely appear in the same sentence: Tesla, SpaceX, xAI, and Intel. And a question that nobody in the semiconductor industry can ignore. Who is really in charge of all this? To understand why Terafab exists, you need to answer a seemingly simple question. What does Tesla actually need to survive over the next 10 years? It's not batteries, it's not motors, it's not factories, it's chips. Every Tesla on the roads today relies on chips to run its autonomous driving system, the FSD. Every Optimus robot needs chips to perceive its surroundings and make decisions in fractions of a second. Every Starlink satellite in orbit requires a specialized chip capable of withstanding cosmic radiation, something you simply cannot find from conventional suppliers. And it was a specific calculation that made inaction impossible for Musk. According to his own estimates, all the chip factories on the planet, combined, can meet only around 2% of the demand that Tesla and SpaceX will soon have. Not 50%, not 20%, 2%. Musk tried to work around this problem by buying in large volumes. A contract with Samsung, signed in July 2025, worth $16.5 billion, was the first response. An impressive figure by any standard, but even that volume does not solve the structural problem. When the most critical component of your business depends entirely on another company, you do not control your own future. That is why, on 21st March 2026, Musk took to the stage at the historic Seom power plant in Austin and said something so direct that the entire global semiconductor industry had to stop and listen. Either we build Terafab or we run out of chips. And we need chips. So we're going to build. There is no plan B. Terafab is a joint chip manufacturing project between Tesla, SpaceX, xAI, and Intel, with an initial budget of $25 billion. The stated goal is to produce 1 terawatt of artificial intelligence computing capacity per year. For context, the United States today produces only 0.5 terawatts in total. Musk wants Terafab on its own to double that figure. What makes Terafab different from any other chip factory is the ambition to integrate the entire production chain in a single location. Chip design, fabrication, lithography, memory production, packaging, and testing, all in Austin, Texas. It is the first time in the history of the semiconductor industry that a single project has claimed to be capable of controlling that entire chain from start to finish in one location. But announcing is easy. Executing is another matter entirely. In April 2026, the diggers began work on the northern side of Giga Texas. This is Phase 1, the prototype phase, covering an area of just over 480,000 square meters on the northern campus of the factory. The goal of this phase is not to produce millions of wafers. The goal is to learn. Production begins with 3,000 wafers per month, a small number compared to what TSMC processes, but it is the foundation. The first chip to be manufactured is the AI-5, Tesla's 5th-generation chip, designed for both autonomous driving and the Optimus robot. Small-scale production is scheduled for the end of 2026, with mass production in 2027. Why start so small? Because Tesla has never manufactured chips before. A 2-nanometer chip factory cannot be learnt from books, nor built by hiring a few engineers. It requires knowledge accumulated over decades, quality control at the atomic level, and thousands of failed experiments before a single wafer meets the required standard. And that is precisely where Intel enters this story. On 7th of April 2026, Intel published an official statement. Intel is proud to join the Terafab project alongside SpaceX, xAI, and Tesla. Our high-performance chip design, manufacturing, and packaging capabilities will help Terafab achieve its goal of 1 terawatt per year. The technology community erupted into immediate debate. One side said that Intel's involvement makes Terafab more realistic and more credible. The other side said that Tesla cannot build a factory on its own, that Intel is the one doing the real work, and that Terafab is just a fancy name on top of a manufacturing contract. The truth is that both sides are right, and that is the most interesting part of this entire story. Intel brings the 18A process, the most advanced on American soil at this moment. It also brings EMIB packaging technology, which allows different types of chips to be combined into a single module with superior performance. And above all, it brings a deep team of experienced manufacturing engineers, professionals that Tesla could not train on its own in just a few years. And what do Tesla and SpaceX bring? Real demand, capital, and a name big enough to change the rules of an entire industry. This is not Tesla failing because it needs Intel. It is Tesla being smart enough to choose the right partner, rather than spending 10 years stumbling through every step of the process. Just look at the track record. Tesla once partnered with Panasonic to manufacture lithium-ion batteries at Gigafactory Nevada. Nobody said Tesla had failed for not making its own batteries from the outset. Over time, Tesla learnt, accumulated knowledge, and developed the 4680 battery entirely on its own. Terafab follows exactly the same path, only on a much larger scale. On 22nd of April 2026, Musk confirmed that Terafab will use Intel's 14A process to manufacture chips. Not the 18A from the initial phase, but the 14A, Intel's next node, more advanced, with a planned launch in 2027. This means Terafab is betting on a technology that does not yet exist on the market. An enormous bet. But if it pays off, Tesla will be the first customer in the world to have chips manufactured using Intel's most advanced process. For Intel, this moment is one of survival in the most literal sense. CEO Lip-Bu Tan had publicly stated that if Intel could not secure a relevant customer for the 14A, the company would consider abandoning the chip manufacturing business. Musk became that customer. Intel's shares rose immediately after the announcement. A single statement from Musk was enough to pull Intel back from the edge. That is the level of real influence that Terafab carries in the global semiconductor industry. As for the long-term future, the phase at Gigatexas is only the starting point. Musk made it clear that Terafab, at full scale, will require thousands of acres at a new location yet to be announced. The projected scale is nearly 9 million square meters, the equivalent of almost 2,000 football pitches. Musk compared the project to Samsung's factory in Texas and said that Terafab will be approximately 12 times larger. But if you are excited about Terafab, it is time to look honestly at the real challenges. Because this is analysis, not advertising. The first challenge is the difference between $25 billion and $5 trillion. Bernstein Research, one of the most respected financial analysis firms on Wall Street, estimates that to genuinely achieve the goal of 1 terawatt of capacity per year, the real cost will be somewhere between $5 and $13 trillion. That is a difference of 200 times the current budget. The fairest perspective, however, is this. $25 billion is the budget for the prototype phase, not the entire project. TSMC built its current position over 30 years and hundreds of billions in continuous investment. The real question is not whether $25 billion is enough. The real question is whether Musk has the patience and resources to see it through to the end. The second challenge is rarely mentioned, but represents a limit that no amount of money can overcome. EUV machines. To manufacture 2-nanometer chips, you need machines that etch circuits using extreme ultraviolet light. There is only one company in the world that manufactures these machines, ASML, from the Netherlands. And its order book is already full until 2027. It does not matter how much money you have, how many engineers you hire, or how much land you own. You still have to wait in the queue. That is a physical limit of the global supply chain that Musk cannot resolve with speed or creativity. The third challenge comes from a completely different direction: water. Giga Texas already consumes more than 2 billion litres of water per year, a 60% increase in just 2 years, making it the third largest customer of Austin Water. A standard chip factory would require a significant additional volume per year, and Austin sits in a region prone to severe droughts. Local environmental groups have already sent formal letters to Travis County Court demanding binding mechanisms should Tesla fail to meet its environmental commitments. This problem has no solution in sight and could become the most unexpected bottleneck of the entire project. Before Terafab, Tesla bought chips from Samsung and TSMC, paid market prices, depended on third-party delivery schedules, and had no ability to intervene in chip design at the manufacturing level. With Terafab, Tesla will, for the first time, be able to optimize its chips down to the silicon level, not just from the software layer, everything designed for Tesla's exact use cases, not for hundreds of different customers. This difference is similar to Apple's transition from Intel chips to the M1 chip in 2020. The result was MacBooks with far superior performance and drastically reduced energy consumption, and Apple never looked back. Musk is betting that Terafab will do for Tesla and SpaceX what the M1 chip did for Apple, only on the scale of an entire industry. Terafab is not a story about a chip factory. It is not a story about Musk wanting to outdo TSMC. It is a story about companies trying to take control of their own future in a world where semiconductors have become a more critical resource than oil. 25 billion may not be enough. Intel's 14A may be delayed. Austin may face water shortages. But the first stones have already been laid. And the history of technology shows that the most questioned projects are often precisely the ones that end up changing everything. What do you think? Is Terafab the vision of the century, or the biggest bet in the history of the chip industry? Leave a comment below. I read every single one and reply genuinely. This channel exists for one reason only: to bring the world's most complex technology news in an accessible, straightforward, and honest way. If this video helped you understand at least one thing better, give it a like. That tells me I'm on the right track. If you think I've missed an important point, say so in the comments, because your perspective is what makes this analysis more complete every day. Share it with that friend who's passionate about technology. It's the best way to help this community grow. Subscribe to the channel so you don't miss the next analysis. See you in the next video.